Hey, I'm Roland Croft. I'm a final year PhD student at the University of Adelaide, and I'm part of the CREST research lab. Today I'll be presenting our paper, an empirical study of developers' discussions about security challenges of different programming languages. This paper is part of the journal first track at ESEC FSE, and of course I'd like to acknowledge the excellent co-authors of this paper, Yongzheng, Mansooreh, Ali, and Christoph. So according to Wikipedia, there are over 700 programming languages currently in use. That's a huge amount, and each language offers different paradigms, functionality, tools, API, and framework support. So with so many languages, how do we choose which one we want to use? Well, usually there's a huge number of factors that may play a role in this decision. The project requirements, our personal experience, learning costs, language popularity, the availability of packages, to name just a few. Whilst such aspects will usually be the main considerations of different programming languages, secure software development has seen an increase in focus amongst organizations, with the continual increase in cyber attacks that we may see in the news. Hence, we may wonder whether choice of programming language has an impact on security. Now, programming languages are built using different paradigms and hence offer different levels of support for security. For instance, a language can perform memory management automatically during runtime, or it can put this onus on the user. These paradigms lead to very different security considerations. In this example here, it shows a very basic out-of-bounds memory operation in a C/C++ program compared to a Java program. Now, C and C++ do not automatically check for out-of-bounds memory operations in this example, as in these languages there's no real notion of the array at runtime. This code can compile and execute without error, and this can be very dangerous as these unauthorized memory operations can easily be exploited by an attacker to view or rewrite memory that shouldn't be available to them. Now, languages like Java though can detect this out-of-bounds memory access at runtime, and it'll fire an error when it sees this. This ceases the execution, preventing the attacker from performing any serious exploits. It's much safer. Consequently, C or C++ programs are significantly more prone to buffer overflow, as they can have untrapped memory management errors due to the lack of static or dynamic checks. Now, consequently, the goal of our study is driven by a simple question: how does the choice of programming language affect secure software engineering? To answer this question, we relied on empirical evidence gathered through the use of different programming languages in the wild. We want to draw insights from practical development cases. Hence, we consult two of the biggest databases of software engineering artifacts and knowledge in the world, Stack Overflow and GitHub. Each site contains a huge number of discussions by developers, and by collecting an appropriate dataset of posts, we can examine our topic of interest. For instance, these two posts provide insights into how developers prevent SQL injection when using the PHP programming language. The Stack Overflow post provides a bit more of a conceptual discussion, whereas the GitHub post is dealing with a specific real-world use case. For the purposes of our study, we consider a Stack Overflow post as a question and its associated answers, and a GitHub post as an issue and its associated comments. Our aim was to look at how these security considerations varied when being handled in different programming languages, and from this we can determine how the secure software development practices change. Now, at a high level, our method follows a three-step approach. First, we identified the 50 most commonly used programming languages based on their frequency of use on GitHub. Consequently, we're using GitHub's definition of what is and isn't a programming language here. Secondly, we collect posts relevant to these programming languages from each data source. For Stack Overflow, we use the tags of a post to determine what language it was discussing, whereas we have the actual language that the repositories are written in for GitHub. We collected the 1,000 most starred repositories of each language when working with GitHub. Thirdly, we refine these posts to only those that discuss the security-related topics, and we do this based on a mixture of keyword and tag matching. Whilst doing this last step, we also filtered out the programming languages which didn't actually have a statistically significant number of security-related posts, and this brought us down to just a set of 15 programming languages for in-depth security analysis. Now, the first thing we wanted to consider was the general security consideration for different language communities based on just how frequently security-related discussion came up. How much of a factor was security in each of these communities? Now, we can see from this graph that it actually varied quite a bit. Security discussions were an average of 1% of the total data on each website, and we can see, maybe unfortunately, that this frequency fell below 1% for the majority of the programming language communities. At the top of the scale, we found that the shell-based languages had the highest rates of security discussion, with 2.6% for Bash and 1.9% for PowerShell. On the other end of the scale, though, we noticed that the languages oriented for scientific programming had the lowest rates of security discussion, around 0.1% for R, Julia, and MATLAB. We just noticed that the users of these languages didn't really have security on their mind, as they're rarely producing customer-facing apps or software. However, security can still be quite an important issue when using these languages. So as to what is actually being discussed, we determined this automatically using the semi-automated approach of topic modeling to assist us. For those unfamiliar with topic modeling, it's an NLP technique to automatically discover the natural topics within a text corpora. We trained a topic model individually for each programming language dataset and tuned the hyperparameters appropriately. Topic modeling revealed there to be 6 main security topics of discussion within each data source: cryptography, access control, network security, data security, software vulnerabilities, and secure development. We further identified 18 subcategories, but in general we found that secure development was the most prominent category of discussion, followed by access control issues. Importantly here though, we see that the distribution of topics can differ quite heavily for different languages. Different topics were of higher or lower focus for each individual language, and not all topics were necessarily relevant. If we go back to our introductory example of C++, we can see that these memory management challenges were only really discussed for this language. Finally, we considered the actual support available for each programming language community. Software development has really become quite a collaborative process, and many people turn to these online communities for support. As we were examining the discussions and challenges in the wild, we were able to actually track how the security issues were responded to and resolved, and we did this through the creation of 3 metrics. Firstly, we have the popularity, which indicates the level of interest and involvement on discussions within the community. We measured this through the number of views and replies and stuff like this. And it's quite desirable for a community to have high popularity, as it can help ensure that the challenges will be able to get a response. Secondly is the difficulty, which indicates the amount of labor or effort needed to resolve a challenge. We measured this through stuff like the time to resolve an issue or the number of attempted solutions. Naturally, it's better if the challenges are of low difficulty. Finally, we have the expertise of the users in the community, which we defined as the level of knowledge and experience of the users for that programming language. It's important that there's a sufficient level of expertise or number of experts able to help resolve the challenges that may arise. So we compare the relative values of these metrics for each programming language. Now, most significantly, we observed the highest popularity values to be for languages oriented for web development, specifically TypeScript and JavaScript. Perhaps correspondingly, we also observed these languages to exhibit the lowest difficulty. This implies that the online communities for these languages may provide better security support than others, as it appears that security is a popular and well-handled topic for web development. Finally, we observed the highest expertise users to belong to communities of languages that were predominantly used for mobile development, Java, Swift, and Objective-C. So, in conclusion, our findings show that the languages exhibit quite varying rates of security discussions, topics of the security issues, and even the characteristics in which these security issues are handled by the community. This study helps motivate the important consideration of the influence that the programming language can actually have on secure software development. Whilst we don't expect security to necessarily become the main factor behind choice of technology, we do simply want to bring it into consideration. Developers should really focus on the security challenges most applicable to their programming language, as we found that not all of the security topics were actually of equal interest and importance during the use of different languages. As security is a very large topic with a huge body of knowledge, developers can maybe reduce their efforts by only revising the most relevant aspects. Our taxonomy of topics can be used for guiding or training of such research efforts. Consequently, we believe that there's an increased need for programming language specific security support and knowledge. Existing state-of-the-art security knowledge and theory is not programming language specific, and we have taken steps towards providing such views. Finally, we found that certain programming language communities require more security support and resources. We found security to be a very small consideration amongst several communities. Furthermore, security topics were not popular or lacking in expertise amongst other communities. Thank you.